Good morning, everyone. Myself Pooja, and today I'm excited to delve into the fascinating world of geothermal power plants. In this presentation, we'll begin with an introduction to geothermal power plants, exploring their components and the various types of available. Following that, we'll delve into the operations of geothermal power plants, examine the landscape of geothermal energy in India, and discuss the advantages, disadvantages, and environmental impacts associated with this renewable energy source. Here we'll see Introduction to Geothermal Energy. Geothermal power as a renewable energy source taps into the Earth's natural heat to produce electricity and offering sustainability. This technology is known for its versatility, reliability, ensuring a steady and clean power supply. By harnessing the Earth's heat, geothermal power plants contribute to reducing greenhouse gas emissions and mitigating the impacts of climate change. With this consistent availability and minimal environment footprint, geothermal energy stands for a promising solution for meeting our energy needs in a sustainable manner. Here we'll see the components of geothermal power plant. Geothermal reservoir. The underground reservoir holds either hot water or steam, both valuable sources of energy. The reservoirs are typically located deep beneath the earth's surface and are accessed through drilling. Wells. These wells are strategically drilled into the geothermal reservoir to extract the hot water or steam. The wells act as conduits allowing the geothermal fluid to flow through surface where it can be utilized for energy production. The electricity generated by geothermal power plant is transferred through transmission lines to a substation. At the substation, the voltage of the electricity is converted to a suitable level for efficient distribution across the electrical grid. Surface processing facilities. Once the geothermal fluid reaches the surface, it is directed to the surface processing facilities. Here, the fluid undergoes separation to remove any impurities and is treated to ensure optimal performance in the power generation process. Generator. The geothermal fluid typically in the form of steam is directed to a turbine connected to an electrical generator. As the high pressure steam passes through the turbine, it causes the turbine to rotate, thus generating mechanical energy. The generator then converts this mechanical energy into electrical energy. Cooling system. After passing through the turbine, the steam or vapor loses its energy and is cooled down. This cooling process causes the steam to condense back into liquid form, ready to be reheated and reused in the geothermal generation cycle. Transmission lines and substation. Once electricity is generated, it is sent through transmission lines to a substation. At the substation, the voltage of the electricity is adjusted to ensure efficient distribution across the electrical grid, providing power homes to business and industries also. Here we'll see the types of geothermal power plants. Dry steam power stations harness the Earth's natural steam directly from the geothermal reservoirs, operating as the oldest and most straightforward type of geothermal power plants, where steam serves as the primary driver for turbine rotation, thereby generating electricity. Flash steam power stations utilize high pressure hot water sourced from geothermal reservoirs, swiftly converting thermal energy into electrical power. Binary cycle power stations employ a distinct process where hot geothermal water heats a secondary fluid with a lower boiling point, in initiating the production of vapor that propels turbines, marking a more intricate but efficient method of electricity generation with geothermal energy systems. This diagram shows how a geothermal power plant works. Hot fluids are brought up from deep underground using wells. These hot fluids spin a turbine which then generates electricity through a generator. After that, the steam which has been used is cooled down in a condenser and turns back into the water. This water is then put back underground, completing the whole process and keeping the environment safe. In this slide, we'll see the geothermal power plant operation. In a geothermal power plant, we'll start by drilling deep into the ground to reach hot water. steam. These natural hot fluids have a lot of energy from the earth's heat. We bring them up to the surface to help make electricity. Once up there, we use them to spin big turbines which are like giant fans. These turbines turn the energy from the hot fluids into a different kind of energy that we can use to make electricity. This electricity then travels through the power lines to reach houses, stores, and factories. It's a great way to make power use. It's clean and comes from the earth's own heat. This slide shows us the geothermal energy in India. The experts estimate that geothermal provinces could potentially generate around 10,600 megawatts of power, although their confidence extends only to about 100 megawatts. In India, geothermal provinces are found in regions such as the Himalayas, West Coast, Sona, Cambay, and Godavari. The first operational commercial geothermal power plant is expected to be established in Andhra Pradesh with a capacity of 25 megawatts, courtesy the Geosyndicate Private Limited. This signifies a significant step forward in harnessing geothermal energy to meet power needs in the region. This diagram focuses on the geothermal energy potential in India. It showcases 7 geothermal provinces across the country stretching from the Himalayas to the Godavari Basin. These provinces hold an estimated potential of 10,600 megawatts of power generation and enough to power millions of homes. However, experts are currently only confident in a capacity of 100 megawatt. That highlights the need for further exploration and development to fully harness this clean and renewable energy source. Here, geothermal power stands out as clean, sustainable energy solution with several advantages over traditional power sources. Utilizing the Earth's internal heat, geothermal power plants offer a renewable energy source that ensures long-term energy security. They emit minimal pollutants, contributing to improved air quality and reduced greenhouse gas emissions. Moreover, their reliability and consistency, unaffected by weather variations, make them a dependable source of electricity. With a long lifespan of low operational cost, geothermal power plants provide an economic benefits alongside environmental ones. While acknowledging potential environmental impacts such as air and water pollution, careful management and technological advancements continue to enhance geothermal energy's role in our transition toward a more sustainable future. Where geothermal power, while offering the numerous benefits, also presents the notable disadvantages. It lands on specific geographic locations, limits its widespread implementation, and the high initial costs associated with building geothermal power plants can be prohibitive. Additionally, challenges in transmitting electricity from remote geothermal sites to polluted areas complicated infrastructure development. Concerns over resource depletion arises due to the potential exhaustion of underground reservoirs over time. Moreover, the construction and operations of geothermal facilities may impact and use the water resources, raising environmental and considerations. Despite these challenges, ongoing advancements aim to address these drawbacks, ensuring the geothermal power's contribution to a sustainable future. In this slide, we'll see the geothermal energy's impact on the environment. Geothermal energy, while cleaner than fossil fuels, still has environmental impacts. It emits some greenhouse gases and uses water, risking pollution. Habitat disruption and rare seismic activity are also concerns. Responsible development is crucial to minimize these effects and maximizes its sustainability. Here are the future aspects of geothermal energy. The future of geothermal power plants looks bright with the technological advancements making growth and enhanced systems like EGS and energy storage. Geothermal energy's reliability, sustainability, and continuous effectiveness position it as a key player in the transition to renewable energy. In conclusion, the geothermal power plants offers a sustainable solution for our energy needs, reducing reliance on fossil fuels and helping combat climate change by harnessing the Earth's natural heat for generations to come. And these were the links we have used for the references and the slides. Thank you.